Good morning, doctor. My name is Vigneswaran, son of Balakrishnan, and my metric number is 211092531. Now we would like to present about hazard on Faculty of Electronic Engineering Technology FKTEN Ping Building. These are my teammates. Okay, now let's quickly introduce about occupational safety and health. Why it's vital for every workplace or lab. For the first one, growing importance. With new industries and complex jobs, occupational safety and health is critical to prevent accidents. For an example, more machines means more potential for harm without occupational safety and health. The second one is government efforts. Malaysian governments through DOSH and law like OSHA 1994 is committed to workplace safety. For an example, DOSH enforce the safety rules in workplace. The third one is key law, OSHA 1994. This law is about preventing risk before they happen and getting everyone, such as bosses and workers, involved in safety. For an example, it's about fixing danger before an accident happens together. For the fourth one, why occupational safety and health matters. Good occupational safety and health protects workers, boosts productivity, and save money by avoiding accidents. For an example, safe workers means better output and no costing injuries after an accident. For the fifth one is hierarchy approach. Hierarchy is a simple way to manage risk. Find the hazard, assess the risk, then control it. For an example, spot a wet floor. It's a slippery risk, so we need to clean it up as fast as possible before meet an accidents. The last but not least is continuous improvement. Occupational safety and health isn't a one-time thing. It can ongoing process to always make sure the workplace is safety. For an example, we keep on checking and improving the safety all the time. Now I would like to slightly brief about the details of optoelectronic lab. For the first one is focus. Studies light-based communication and devices. For an example, like the technology behind fiber optic internet. The second one is crucial for FYP. Key lab for students final year project in these technologies. For an example, students can build and test light sensor here. For the third one is, this optoelectronic lab is managed by Encik Muhammad Yushairi bin Rosni. He is the assistant technician of this lab. For the fourth one is hands-on experience. Offer practical work with advanced light and electrical gears. For an example, students can use the real lasers and detectors. There are 4 types of equipments in this lab. The first one is TM4000 plus microscope for super detailed imaging. For an example, used to see tiny parts of the materials. The second equipment is Explora plus Raman microscope for chemical analysis of materials. For an example, to identify what is the materials is made of. The third equipment is optical waveguide alignment system. Precisely line ups optical parts. For an example, connects tiny light fiber properly. The fourth equipment is harmonics optical amplifier. Boost light signal for communication. For an example, make sure the data transfer far in fiber optics.
Salam sejahtera. My name is Jivinesh Analaki Murgis, metric number 221092180. Today, I'm going to present on the hazard classification of equipment for our project. So, as you all know, our project is based on the FKTEN building, which is the pink building. So, from our identification, the most hazardous equipment there was the optical waveguide alignment system. This is because it is high power laser and also it can risk for eye injury. And the another most hazardous equipment was the harmonics optical amplifiers. It can make invisible high power infrared laser which can cause electric shock rises. So if students or anyone uh, touch it accidentally, so it can cause a very big damage to their health. The next hazard classification is the moderately hazardous. For this, the first equipment is the Explorer Plus Raman microscope. It is used for laser exposure risk, which requires protective eyewear. So, if we didn't wear any protective eyewear handling this machine, it can make us become blind. The second equipment is the TM4000 plus microscope. It uses high voltage and also X-ray with vacuum system risk. And finally, for the hazard classification is the less hazardous. For this, it is on the workstation or benches. It is low risk, potential minor, ergonomic, and trip hazards. For example, when we find when to find out the hazardous, we found out that there was a chair, broken chair. So when the student is going to sit on it, it may cause damage to their health, but it is not a high risk, only a low risk damage or hazard for the people itself. And the second is the Newport optical table. The Newport optical table, which can be seen with the horrible Raman microscope, is not dangerous by itself. It gives experiments a reliable platform. Okay, that's all for the hazard classification of equipment. Thank you.
My name is Paitra Ashwini Nagaraju, metric number 2210911133. Today I am going to present about hazard identification. What are the first hazard in the lab is laser radiation explorer plus Raman microscope. What are the risks is laser exposure class 3B laser. For example, like a laser pointer but much stronger, this can burn our eyes instantly. The secondary risk is chemical fumes like electrical shock and mechanical injuries. For example, if we use chemicals during testing, fumes can be released. Also, touching the wrong part can give a shock or cause small pinching injuries. The second point is risk assessment. Probability low with the safety protocols. For example, if everyone follow the rules, it's very unlikely to get hurt. Second point is severity, very high permanent eye damage. For example, but if an accident happens, someone can lose their eyesight. The initial risk is high control risk with a proper measure. For example, it's dangerous at first, but we can make it safe with the right equipment and training. The third point is risk control. First, in engineering, beam stops, automated shutters and enclosures. For example, the laser turns off automatically when we close the cover. Second, administrative laser, safety officer, operator training, emergency protocols. For example, like attending safety training before using it and having someone in charge to handle the emergencies. PPE, laser safety eyewear. For example, we must wear special laser goggles, not normal glasses won't protect us. The second hazard identification is UV light optical waveguide alignment system. What is the risk is UV light exposed causing eye and skin injury. For example, just like a sunburn from the sun, UV from this machine can hurt our eyes and skin badly. The secondary risk is thermal burns, pinch points and electrical shocks. For example, touching hot surface can burn you and getting fingers caught in moving parts can injure you, like closing a drawer on your hands. The second point is risk assessment. Okay, probability moderate with the fault equipment, or deteriorate for the protocols. For example, if the machine is damaged or if we skip safety steps, accidents are more likely to happen. In severity, high, high and skin damage. For example, if exposed, you could not end up with a serious eye injuries or skin burns. Third, initial risk is high without control measures. For example, using the machine without any safety precaution is very dangerous. The third point is risk control. First, in engineering, enclosures, interlocks, automated system, and shielding. For example, the machine has a cover that blocks UV light and sensors that stop it if open. Second, in administrative regular maintenance, SOPs and trainings. For example, we have a standard procedures and regular checks to make sure everything works properly. The third one is a PPE, UV protective glasses, gloves and clothing. In lab, just for example, just like wearing sunscreen outside, we wear special glasses and gloves to block UV rays. The third hazard identification is invisible high power laser radiation harmonic optical amplifier. Okay, the risk is invisible high power laser exposed causing several eye injury. For example, this laser is dangerous because we can't see the beam. So you won't even know if it hits your eyes. The secondary risk is heat build up electrical shock. For example, this machine can get very hot and touching the wrong part might give an electric shock like a fault plug. The second point is risk assessment. First, in the probability, minimal with the proper training and protocols. For example, if users are well trained and follows the steps, the chance of accident is very low. The second severity risk assessment is extremely high due to invisibility to the laser. For example, because it's invisible, injuries can happen before you even realize it, making it more dangerous than visible lasers. The third one is initial risk, high without safety controls. For example, if the system is used without safety measures, it's very risk to the eyes and health. And the third point is a risk control. In engineering, enclosures, interlocks and emergency stops. For example, the system has a safety covers and sensors that shut it down if opened, plus a red emergency stop button. The second administrative is SOPs, trainings, laser safety officer. For example, in this, all users must be trained, follow the written procedures and report to the laser safety officer. The third one is PPE, laser safety eyewear. For example, we use a special goggles to design to block the specific invisible laser light. It will be protect our eyes. Thank you. That's all from me.
Okay, now let us see on the fault hazard. The fault hazard is the mechanical risk on the Hitachi TM4000 Plus tabletop microscope. On the first, let's see on the hazard identification. The first risk is pinch or crush injuries from the sample stage, and the secondary risk for this equipment is that it can cause electric shock, X-ray emission, or also vacuum system hazard. The risk assessment of this is for the probability it is moderate due to frequent handling. Uh, Furthermore, its severity moderate to high from brushes to fractures or electrical shocks. And finally, in the initial risk, it is only moderate. For the risk control method, based on the engineering part, safety interlocks, emergency stop, or shielding can be taken to control the risk. For the administrative SOPs, operator training and maintenance should be done to make sure to less the hazard. And for the PPE, gloves and safety shoes must be worn when handling this equipment. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adan Mizuki. My method number 22292101. Okay, for the last hazard, which is electrical conduct hazard. Okay, for the hazard identification, Okay, this is serious electrical hazard because the conduit is rusty with the crack and open gaps, which may expose the live wire that can lead to electrical shock, burns, fires, or short circuit. Okay, according to the electrical regulation 1994, only trained and qualified people are allowed to handle this electrical work. But in this case, the damaged conduit is unsafe, especially in the lab used by students and staff. Okay, for the risk assessment, we assess the hazard is having a moderate to high chance of happening because it is a common error and clearly worn out. The severity is high because contact with the live wire can cause the serious injury or even death. Using the hierarchy metric, it is considered as a high risk. That means the action must be taken. Okay, for the lastly, risk control. Okay, we cannot remove the conduit completely since it is needed for the power. So we can use three level control. The first control is engineering control by replace the damaged conduit with new insulation piping. Okay, for the cycle control is at the mas at the administrative control. Do legal check, put the outlining sign, and report any damage quickly. And the last is PPE. Workers doing the repair must wear the rubber glove and use insulation tools to protect themselves. Okay, in conclusion, the hazard is dangerous and must be not be ignored. By fixing it quickly, we protect everyone in the lab and follow both legal and safety standards. Thank you. That's all for me. Okay, next. By addressing this hazard, we not only protect life, but also promote a safety first culture among the student and staff. These are responsible future engineers who carry the strong OSH value into this career. From the environmental perspective, reducing the electrical hazard also prevent fire outbreaks, limit the population, and reduce waste by extending the equipment life. It supports both safety by sustainability goals, aligns with the OSHA 1994 and ISO for 14001. Okay, in conclusion, this hazard may look small, but it reflects in deeper issue in maintenance and safety culture. Fixing it properly, fixing it properly is not just compliance; it's a because it is a professional and ethical duty. Okay, that's all from me. Thank you.
For the conclusion, there are 5 main points for this. The first one is a successful hazard identification. Our project successfully found the danger about the hazards in the lab and understood the risk involved. For example, we pinpoint specific risk such as laser, explosion, and electrical hazards. The second point is risk control measure. We suggest the right way to control this risk, which will make the lab more safer. For an example, this includes proposing things like safer goggles and proper wirings. The third point is safety awareness. This project highlighted how important it is to have safety first mindset, especially in an academic setting. For an example, it shows that everyone needs to be proactive about safety, not just reactive. The fourth point is regulatory compliance. We emphasize following all safety laws, particularly Malaysia's OSHA 1994 and the Factories and Machineries Act. For an example, ensuring we meet legal requirements like from DOSH. Last but not least, the fifth point is long-term impact. This project will help create safer and healthier place to work and teach future engineers to be responsible about safety. For an example, it's about build a strong safety culture for tomorrow's professionals. That's all from us, Doctor. Thank you.